Check your answers for 31 through 34. (31) asks which of the following graphs represents a non-linear function. So non-linear means not a line. So we look at these four. Which one of them is not a line? That's B. (32) asks which of these tables represents a linear function. Now, you've got a couple of options. You could graph these and you could see if they made straight lines. That's one option. You could draw your own graphs, you could plot these points, you could see if they were in a line. The other thing to check is the slope. Linear is going to have a constant rate of change. That means the slope is going to be the same regardless of what 2 points we choose. Okay? So let's look at these. Let's look at the first one. What do? We go up 2 over 1. Then we go up 3 over 1. Is that constant? Does 2 over 1 equal 3 over 1? No, not a line because the rate of change is not constant. Now, let's look at part B. How do we get from -5 to -1? We go up 4, -7 to -10. We go down 3. Remember to use your number line if you need help with that. How do we get from -1 to 2? I think we go up 3, down 3. Is 4 over -3 the same as 3 over -3? No, not a constant rate of change. Let's look at C. How do we get from -4 to -1? Is that up 3, 2 to 4, up 2. -1 to 2, up 3, 4 to 6, up 2. This is promising. 2 to 5 is +3, 6 to 8 is +2. So this one appears to have a constant rate of change. Let's see what's going on with the next one. 3 to 0, down 3, up 5, right? 0 to -3, down 3, up 5. Uh-oh, are they trying to trick us? -3 to -6, down 3, but this one's up 3. So D doesn't work. So this one is 3 over 2 every time. It has a constant rate of change. That means it's a line. Next, they give us equations, and they ask us which is a linear function. Which of these would make a line if we were to graph them? Well, the only equation you're familiar with linear functions is slope-intercept form. Are any of these in slope-intercept form? Y equals mx plus b? That one's going to be a line. Notice A has an exponent. Anything with an exponent, 3 or 2, whatever the exponent is, not going to be linear. Those are other special shapes. Notice D has x in the denominator. We've not seen that with a line. That is not a linear function. This right here is slope-intercept form, so it is the equation of a line. Now, look at 34. They've given us a graph, they've given us a table, they've given us some equations, and they want to know which one is linear. Well, look at A. Is that a line? No. Let's look at the equations. Have we ever seen a linear equation with an exponent? Not possible. Not a linear equation. That's we can get rid of that. Look at D. Do we ever put x in the denominator of a linear equation? No. So the only thing we need to check is the table. Now, by process of elimination, we would say B, but let's check. What do we check in a table? We check for the constant rate of change. So let's look. 0 to -4, down 4. -4 to -8, down 4. -8 to -12, down 4. How do I get from -5 to -2? Add 3. -2 to 1, add 3. And 1 to 4, add 3. Notice I have -4 over 3, -4 over 3, Negative 4 over 3, that's a constant rate of change. That means that's a line.